Hello everyone. So my name is Indhumathi. I am assistant professor in electrical electronics engineering in PSN College of Engineering and Technology, Tirunelveli. So today my topic is electric vehicles and hybrid electric vehicles. So why we use electric vehicles and why we use hybrid electric vehicles, and what are the advantages and disadvantages and working of electric vehicles and working of hybrid electric vehicles. So these are all the content of our today's topic. So first of all, need of electric and hybrid vehicles, because all of you know about we are all dependent on petrol or diesel. Because of all vehicles, most of the vehicles in our India run by petrol or diesel. So we deeply depends on petrol or diesel. That's why we need electric and hybrid vehicles. So at the same time, the problem of rising petrol and diesel prices, because of the petrol and diesel prices increases day by day. So that is the most serious problem vehicle users. So that's why we need electric and hybrid vehicles. So and pollution. So this is the main reason, the pollution and the resultant global warming. So the petrol or diesel pollute our environment. So that is reasoning global warming. So that's why we need electric and or hybrid vehicles. And noise in conventional vehicles, and need for alternate power sources, and need for eco-friendly, and EV/HV the solution for good vehicles. So these are all the need of electric and hybrid vehicles. So in this term electric vehicle, that is pure EV. So the vehicles only run by battery storage. But in a hybrid vehicle, the vehicle depend upon internal combustion engine and as well as battery. So the graph shown world oil production from 1900 to 2080. So in 2080, high demand in world oil production. So it's very difficulty to our vehicle user. That's why we are need to change our mindset from internal combustion engine to electric and hybrid vehicles. So these are all the need for electric and hybrid vehicles. And now, what is electric vehicles? All of you better know about what is electric vehicle, but I will mention. An electric vehicle is an automobile that is propelled by one or more electric motors using electrical energy stored in an energy storage device. So laterly we discuss about the energy storage device, but common name is battery. Okay. So with the help of motor, the electric vehicles are propelled. The primary components of electric vehicles are motor, controller, power source and transmission. So the controller is the main heart of our electric vehicles. And then block diagram. So from this block diagram, we are understand the working principle of our electric vehicles. So the electric vehicle, the principle is it convert electrical energy into mechanical energy, because of the input source of an electric vehicle is battery, that is electrical energy, and the output source is wheel, that is mechanical energy. So the battery is charged by charger with the help of our charging station and other else. So if the battery is fully charged or the battery is a particular level charged, then the vehicle ready to run. And then the battery power is given to the power converter. Because of we may suppose used the electric motor as in AC motor or DC motor. That's why we need power converter. So the power converter not only convert AC to DC, it also boosts up the voltage from one mode to another mode. So this purpose are power converter. Then electric motor. So now the electric motors are running, and with the help of transmission drivetrain, then wheels are rotate. So these are all the electric vehicle system block diagram. And advantages. So we will use the electric vehicle by this advantages. No gas is required. So no gases or no fuel, that means no petrol, diesels are required in this vehicle. And from this no requirement, we reduce the emission. No, we reduction the emission, that means no emission, and also cost effective. So compared to IC engine vehicle, the maintenance cost is very low. That's why it is cost effective, and as well as low maintenance and payback period. That is also very good advantages, and low noise. So if we use the IC engine, the noises are raised, but in the electric vehicle there is no gases, no IC engine, and no petrol or diesel. That's why the noises is very low. And we have some disadvantages in this current situation. We have some disadvantages. Highly initial cost. So the compared to other petrol or diesel vehicles, it may lead to high initial cost and short driving range. So because of, if we fully charged vehicle is run up to 400 km only. So that's why it is short driving range. But the electric vehicles are in still now, this is all research condition. So that's why the researcher definitely rectifies the disadvantages. And recharging takes much longer time than refueling oil, lack of charging infrastructure. Yeah, because of the charging time is much longer compared to diesel or petrol vehicle. Because of, if we want to fill the petrol to a vehicle, we no need to spend so much of time to filling the petrol, but in the recharging the vehicle we have spent a lot of times. But we have ultra fast charger in electric vehicle, but they have also 30 minutes to take the charging fully charged. So comparatively its recharging take much longer. And lack of charging infrastructure, because of we have a gasoline station and fuel station in one street. We have per street we have a 2 or more refilling station, but the charging infrastructure is very less compared to this refueling the gasoline station. And battery pack takes space and weight of the vehicle, which otherwise is available to the people. So that is battery pack. So that is occupy the more space in the vehicle. So that's why it is very some disadvantages. But the weight of the vehicle also increase. So these are all the disadvantages. But in researcher definitely rectify this all the disadvantages. Now we will move to hybridization. Because of we have some disadvantages. Short driving ranges, recharges make longer time. So that's two advantages are most people facing this problems. So from this disadvantages we used instead of electric vehicle hybridization. So the hybridization means multiple source of power. That means it's a combination of IC engine and battery. So it working principle as well as IC engine principle and also EV principle. Because of if we used only IC engine, so it may affect our environment and it cause global warming. So a combination of IC engine and EV, so that's much less than less reduce than emission to environment. So that's why we use hybridization, hybrid vehicle. So the meaning of hybrid vehicle, the term hybrid vehicles in general usage refer to vehicles with 2 or 3 different types of sources delivering power to wheel for propulsion. And the most common hybrid vehicle have IC engine and 1 or more electric machines for electric propulsion. So that's why I already told it is the combination of IC engine and the electric vehicle. So the IC engine can used to generate electric energy on board to power the machine. So from this IC engine, it's acted as a generator. So from this generator, from the mechanical power or any other power to electrical power, then electrical power is given to the battery or any other else storage system, and then the vehicle run by the electrical energy. So that is hybrid vehicles. Then classification. We have some classification, we have some architecture also. So the classification means mechanical power transmission path and electrical power transmission path, and combination of mechanical power transmission path, electrical power transmission path, and based on architecture series, parallel and series parallel. So first we will discuss mechanical power transmission path. So in the classification, mild power energy, there are 3 degrees. So charge depleting and charge sustaining. First we discuss mechanical power transmission path. So the mechanical power transmission path, it is the IC engine vehicle. So it's depend upon a fuel. So the vehicle run by IC engine, that is the primary powertrain components is a conventional ICE vehicle, that means internal combustion engine, okay, and transmission. The energy flow in the vehicle start from source of energy and end at wheel with delivery of propulsion power known as power transmission. And then electrical power transmission path. So in electrical vehicle, power transmission is almost electrical except coupling devices. So between electrical propulsion motor and wheels. So this coupling device can simply be a gear to match electric machine speed to vehicle speed. So look at the block diagram. Compared to previous, it is fully depends upon the fuel, but in this case it is not depend upon fuel, there is energy storage. So I literally discussed about energy storage, that is the main battery. Then combination. So this is hybrid vehicle. The propulsion power is transmission to wheel through either MPTP, that means mechanical power transmission, and electrical power transmission, or combination of both. So the MPTP is associated with the IC engine and transmission, whereas EPTP consists of energy storage, a generator, propulsion motor and transmission. Then the hybrid electric vehicle powertrain block diagram. So the main component is internal combustion engine, but in this case the electric vehicle, if the fuel are fully drained, the vehicle run by electric power, that means battery. So that is the shown. So first of all, the internal combustion engine electric vehicles are run. If the fuels are fully drained, so the vehicle depend upon the battery. If initially the vehicle is run by battery, if the battery is fully drained, the electric vehicles then run by internal combustion engine. So the process is again and again repeated happen. As well as the electrical energy storage is charging during the vehicle running with the help of internal combustion engine, okay, and give the power to the electric generator. The generator give power to the energy storage system. Then we have some classification, that is architecture. So that is series HEV, parallel HEV and series parallel HEV, that is hybrid electric vehicle. So a series hybrid is one in which only energy converter can provide propulsion power. Only electric motor provide all propulsion power to wheel, and the downside IC engine drive the generator with a supplement battery and can charge them when it fall below certain charge level. So that I told already. The drawback is size of traction motor, which has to be rated off for maximum and power requirement of vehicle. And then block diagram, the series HEV block diagram. So in this case, the battery and the engines are series connection. That is the main concept in a series hybrid electric vehicle. So after that, we will connect the motor and converter and transmission and differential, and differential output is given to the wheels. So before the battery we will connect the generator as well as converter, so to generate the electric power to the battery. So advantages, then it is a flexibility of location of energy generator set and simplicity, then suitable for short trip with stop and go traffic. And then disadvantages, it need IC engine generator and motor must be designed for maximum sustained power that vehicle require, such as climbing a high gradient. All drivetrain components need to be sized for maximum power for long distance high speed driving. So these are all the advantages and disadvantages of the series hybrid electric vehicle. Then parallel. So in this case, the parallel hybrid is one in which more than one energy conversion device can deliver propulsion power to the wheel. The IC engine and electric motor are configured in parallel with the mechanical coupling. The power requirement of electric motor is lower than that of series IGV. So power requirement is very low. Then block diagram. So in this case, engine and batteries are parallel connection, but in series hybrid electric vehicle, the engine and batteries are series connection. So that is the difference between the series and parallel hybrid electric vehicle. So from this, after the battery, we will connect the motor, then transmission, and the vehicles are run. After the engine, the clutch will work and the transmission happen and the wheels are run. Then the advantages. It's need only IC engine and motor generator. A smaller engine and motor can use to get same performance until battery are depleted. Disadvantages, and the control complexity increases since power flow has to be regulated and blended from two parallel sources. So these are main disadvantages. Yeah, this happened during running. The power blending from IC engine and motor needs to be complex mechanical device. Then series parallel IGV, because of its combination of series and parallel. So in this vehicle, it combined the benefits of series and parallel architecture with charge sustaining capability. The power split device divides the output from the engine into mechanical and electrical transmission parts. Even IC engine is also used to charge the battery. Yeah, this has happened in a series parallel. So they are capable of providing continuous high output power compared to series or parallel powertrain. So these are mainly used because of it gives continuous power to the vehicle. So block diagram. So the battery and the engine, these are all series connection as well as parallel connection. So the engine is connected to the vehicle. So the vehicle run by engine, that is a individual path. At the same time, during running the vehicle by using engine, the engine also give power to the battery to charge the battery. So if we fully drained the petrol or diesel, and now the vehicle is run by battery because of with the help of IC engine. So this is the series parallel combination of HEV. Then drive mode operation, I already told. So please all of you carefully see the arrow mark. Electric vehicle, this is a pure electric vehicle. That's why they mention the vehicle run by battery only, and a hybrid electric vehicle. So the vehicle run by engine as well as battery, and the battery charging method. So in this hybrid electric vehicle, we have battery charging method also there. So that is, from this engine the vehicles are run, as well as from this engine the batteries are charging, and regenerative braking. So with the help of output, that is meaning of wheel, we generate the regenerative braking, and the electric power is stored back to battery. So these are all the drive mode of operation. And torque characteristics. So electric motor and IC engine torque characteristics. So these are the motor characteristics. So in this case, the torque will initially high, and then step by step the torque is reduced but speed will increase. But in the IC engine the torque is initially low, but the step by step the torque will increase and the speed will gradually increase. Then if we may meet the certain point, then it will maintain the constant torque and the increase the IC engine. So these are the torque and the power of an IC engine and electric motor. So the torque characteristics. The torque characteristics of a motor is shown along with the torque characteristics of IC engine. So for I already told, for electric motor a high torque is available at starting, so which is the rated torque of motor. The peak or rated power from the motor is obtained base speed when motor characteristic enter the constant torque power region from constant torque region once voltage limits of power supply is reached. The motor rated speed is at end of the constant power region. The IC engine peak power and torque occur at the same speed. So the mode of operation. So I will give practical application Toyota Prius, the mode of operation. So startup and acceleration, engine may be shut off, and cruise the gas petroleum engine operating is maximum efficiency. So these are the maximum efficiency, and this is the battery. So the acceleration is very much peak compared to gas or petrol, and then constantly maintained. Then engine is shut off, the vehicle is run in straight line, but in the deceleration and braking the vehicle is an electric vehicle run is lower to higher. So these are the comparison of energy in electric as well as gasoline engine. So commercial vehicles, I already told Toyota Prius and Toyota Highlander and Ford Escape and Mercury Mariner and Honda Insight, Honda Civic HEV, Honda Accord HEV. These are the commercial vehicles in hybrid electric vehicles. So hybrid model and non-hybrid model. So hybrid model Honda Accord hybrid model and Honda Accord XL is 2014 non-hybrid model as also. So in hybrid vehicle we spend $3,335. So weekly we mention some more amount. So these are all the comparison between the hybrid model and the non-hybrid model vehicles. Then challenges. Time of battery changing is long. So we have more much of time, then we spend to change the battery. Batteries are heavy, 100 kg, extra weight consume 12 and per 100 kg 2 liter, and the batteries are expensive, and low performance is in hot or cold temperature also may damage the battery. Very sensitive to overcharge, undercharge, battery life reduces dramatically. So contain toxic heavy metals, disposal issue. So these are all the challenges in our electric vehicle as well as hybrid electric vehicle. So definitely the researcher in future they will rectify these challenges. Advantages: environmental friendly. So the main advantage is environmental friendly, financial benefit, less dependence, and regenerative braking systems are available in an electric vehicle, and normal IC engine vehicle they have no facility in regenerative braking, but in electric vehicle we have facility in regenerative braking system and built from lighter materials. Then disadvantages: less power, expensive, poor handling, high maintenance cost. A hybrid car. So now I conclude the electric and hybrid vehicle. Using the concept of hybridization of car result in better efficiency, also saves a lot of fuel in today's fuel deficit world. A hybrid gives a solution to all problem to some extent. One can surely conclude this concept will follow with even better efficiency and conservation rate. So environmental oriented and fuel cost oriented, we will move to electric or hybrid electric vehicle. Now we will go to the topic of energy storage system. So in electric vehicle or hybrid electric vehicle, the energy storage is very important topic. So that's why I will teach energy storage system. So what is the importance of energy storage? The transition from non-renewable to environmentally friendly and renewable source of energy will not happen overnight, because the available green technology do not generate enough energy to meet the demand. Developing new and improving the existing energy storage device and medium to reduce energy loss to the minimum, lower the cost of energy storage and maintain the reliable power supply. Why energy stored? Energy stored use various methods. Store excess energies to the used at later time, which will then allows energy provided to balance between the demand and supply. A number of devices and media are used to store energy, while their selection depends primarily on the store of energy and the use. Types of energy. So these are all of you very well know the types of energy. The chemical energy storage, vanadium, it is used in vanadium redox battery. And electrochemical energy storage, the chargeable and rechargeable. We mainly use the electrochemical energy storage in an electric vehicle. So chargeable and rechargeable and fuel cell. Then electric energy storage system, that is a capacitor and supercapacitor, the thermal energy storage system. Storing harvested kinetic energy. As we have small energy value 9 millivolt, the option are supercapacitor, lithium ion battery. So these two are very good in have small energy value. Supercapacitor. So these are the double layer supercapacitor. This are instead of battery. If we wish use supercapacitor, your choice. So double layer capacitor, electrical component that are used to store electrical charge, but as it name reveals, supercapacitor. So that is electric charger, can store more electric charge, but we have more of capacitor. The capacitor is typically used as short-term backup power only. It is a short-term backup power. While supercapacitor can also use to power large engine, including vehicles, as supplementary storage for battery electric vehicles. And now electric double layer. So in the if we have it's the same type of battery, we have a two plate, one is anode, one is cathode. We have electrons, we have positive, and we have electron, we have a separator, and electrical double layers. If we during charging the positive ions are moved to negative ions, during discharging the negative ions are moved to positive ions. Such energy storage has several advantages related to batteries. That is very high rate of charge and discharge, good reversibility and high efficiency. The efficiency rate is 95% or more. Disadvantages. The amount of energy stored per unit weight is considerably lower than that of electrochemical battery. So that is 3 to 5 watt hour per kilogram for electric capacitor compared to 30 to 40 watt hour per kilogram for a battery. It's a very nice, but it is very much disadvantageous because of the battery is used is 30 to 40 watt hours, but it is 3 to 5 watt hours. It is also the voltage varies with them. Energy storage to effectively store and recover energy require sophisticated electronic control and switching equipment. Lithium ion battery. Lithium ion battery. Now we move to lithium ion battery. So this is a mainly used battery in an electric vehicle, a hybrid electric vehicle. So that is energy storage device and conversion of chemical energy, and this closed system. So these are the electric lithium ion battery. So the flat shape is used in laptops or phone, but the cylindrical shape is used in an electric vehicle. So electric vehicle lithium ion batteries are now being widely used for application such as powering a laptop, computers, mobile phone cameras and many more devices. The high energy density that the lithium-ion battery provide enables the electronic devices their power to recharge. Advantages: high energy density and does not need priming when new. One regular charge is all that needed. Relatively low self-discharge and low maintenance. No periodic discharge is needed. There is no memory, and specialty cell had provide very high current to the applications such as power tools. And we have some limitations also. Require production circuit to maintain voltage and current within safe limits. So we have a production circuit also. Now, and the storage in a cool place at 40%, charge reduce the aging effect. So the cool may be reduce the 40%, so the aging is effect. Then expensive to manufacture, about 40% higher in cost than nickel cadmium. So compared to nickel cadmium battery, the lithium ion battery is very high cost, not fully mature. That means metal and chemical are changing on continuous basis. Now the comparison between supercapacitor and lithium ion battery. So in the function of charging time, supercapacitor takes 1 to 10 seconds because of this short time backup. But lithium ion takes 10 to 60 minutes. That means it's 1 hour. And cycle life 1 million or 30 hours. But in this case 500 and higher. Cell voltage 2.32 to 2.75 volt. But in the lithium ion case 3.6 to 3.7 volt. And specific energy whatever 5 whatever. But in this case 100 to 200 whatever per charge. Specific power up to 10,000, but in this case 1000 to 3000 watts. Cost just 20, but in this case 0.5 to 1 for large system. Service life 10 to 15 years, but in the lithium ion battery 5 to 10 years. And charge temperature -40 to 65 degree, but the lithium charge it's 0 to 45 degree Celsius only. If we increase the 45 degree Celsius, the battery may cause to expand. The discharge temperature -40 to 65, but it is -20 to 60 degree. So these are the comparison between supercapacitor and lithium ion, and this is a performance comparison. So then graph, it indicates a graph. So supercapacitor, the yellow color means supercapacitor. So sudden increase, sudden decrease. Suddenly they charge the vehicle, suddenly they discharge the vehicle. This is short term pack. But the rechargeable battery, the charging is constantly happen, the discharging is constantly happen. So these are comparison between the supercapacitor and rechargeable battery. So if you want to know about the supercapacitor, go to visit this link. So thank you for watching this video. Thank you.